Alright, so here a car of mass 1800 kilogram rounds a circular turn of radius 20 meters. It says the road is flat and the coefficient of static friction between the tires and the road is 0.68. How fast can the car travel without skidding? So in this particular diagram, you're provided with a bird's eye view and then also a rear view. So bird's eye view is what this car looks like as it tries to make a left here or around this curve. The blue arrow represents the force of static friction. It represents sort of the force of static friction is because the problem states that you are trying to make this turn without skidding. Skidding would imply that the car is going to go off in some sort of tangent or lose control here, but you don't want to. You want to be able to make this turn safely. So you need enough force to keep that happening. Okay. Here's just the rear view, which allows us to find or to draw your free body diagram. All right, so here I will go ahead and call this force in the bird's eye view. That is the force of static friction that is going to keep the car in its lane to make this turn safely without skidding. On the bottom diagram, this F of S here, looking from the rear end, will be pointing towards the left. So that is F of S. Again, this is just two different perspectives for you. And then as the car is driving on the road, it is making contact with the road. So here the car has a weight which keeps it on the road. And then the road is pushing back up on the car with equal force. It's just opposite in direction. So here the vector that's pointing down is the weight of the car, or aka the force of gravity, which is equal to mass times gravity. And then the force that the street or surface exerts on the car is called F of N, the normal contact force. All right, so now that we know that, let's go ahead and crack this one out. This one's pretty easy to do. All right, your centripetal force in this case is contributed to the force of static friction. Okay, but you know the function for centripetal force. Well, hopefully you do. The function for centripetal force is mass of the moving object times the tangential speed squared divided by the radius, or the imaginary circle here. All right. And then the force of static friction is defined as the coefficient of static friction times F of N. But you notice here I highlighted F of N because I don't know what F of N is. But what I do know from this rear view perspective is that the normal force is the force exerted by the floor onto the car. But the car is going to, again, push down on the road with equal amount. So here I know that F of N is equal to F of G. So what I can do is I can substitute out F of N for F of G. The left side I haven't done anything. I just kept it the same. Okay, so the only thing I've done different here is I substitute out for Fn for F of G. Why? Because I know what F of G is. F of G is the mass of the car times the acceleration due to gravity at the surface of the planet. However, if you notice here, mass appears on both sides, so I'm going to go ahead and cancel that out. Okay, so even though the problem gives you the mass of the car as 1,800 kilograms, you actually don't really need it, right? So as you practice physics, look at functions and look at what it depends on and what it's independent of. So here, the mass of the car, even though it's given to you, you don't need it because it cancels in this particular expression. Now, we're trying to find how fast, so therefore I want to find V. To get V by itself, I want to go ahead and multiply both sides by R and then square root. Okay, so here, I'm just going to multiply both sides by R, or I like to just move the R in the denominator here up to the top right. So that would be mu SGR, and then here we have V squared. Now, to just solve for V, we just take the square root. Okay, so radical both sides, we'll get rid of the exponent. And then, now we have everything. We have the coefficient of static friction is given us as 0.68, G is 9.8, and then R here is 20 meters. All right, so I'm just going to plug in 0.68, 9.8, 20. I'll multiply that and then square root that. And if you do that properly in calculator, you should get about 11.54 meters per second. And since this is how fast, I'm just going to give you the tangential speed here because the tangential velocity changes all the time. Because velocity is a vector, it has a magnitude and a direction, but as a car turns, its direction continually changes. So here, I'm just going to provide you with the tangential speed. It says how fast, it didn't ask for velocity, so I'm just going to keep it as that. All right, that's your answer for this one. Here's the next example, all right? Similar, except you're just solving for a different quantity. Here it says a 1,400 kilogram car travels at a constant speed of 35 meters on a flat surface around a circular path of radius 135 meters. It says determine the minimum coefficient of static friction needed in order for the car not to slip or skid. All right, so same problem really, except instead of solving for V like we did in the last one, here it asks for us to solve for mu s. So for practice, I want to set up the same statement. my centripetal force for these types of problem comes from the force of static friction, okay, between the tires and the road. Well, F of C, once again, can be broken down into mass times v squared divided by r, and then F of S is mu S of n. But here, Fn can be moved down to the left side because I'm trying to find mu S. So when you want to substitute, that's up to you. But I notice here I have mu S times Fn. So I will go ahead and isolate for mu S, simply dividing both sides by F of n. Or I'm just going to circle Fn, and I'm just going to move it to the left side, and that goes in the denominator. Okay. Now, here you can break up F of n into F of g. And then once again, you can break F of g up into m times g. So you notice here mass cancels out. And so the only terms you have left is v squared, r, and g, which you have. The problem gives you v is 35 meters per second, r is 135, and then g you already know. So I'm just going to make sure I square this because the function is square, and then divide by that. If you punch all this stuff in your calculator, I got about 0.93, okay? And the coefficient of static friction has no unit, it has no direction. Therefore, that is just my answer for for the second question here in this video. All right. Next is the ratio problem. Here's the diagram I just carried over. It says if a certain car going with speed v rounds a level curve with the radius r, it is just on the verge of skidding. If its new speed is now double, and it wants us to find the radius of the tightest curve on the same road that it can round without skidding. So essentially you have two scenarios. Scenario one, you're moving at speed v with the radius r. Now you're going to double the speed, and it wants to know how big that radius is before you lose control of the car, okay, or before it skids. All right, so I'm just going to go ahead and do a little chart before and after, and then I'm just going to use the function that I derived in the first two example problems for this video. V squared is equal to the coefficient of static friction times g times r. From here, I'm just going to actually isolate for r by dividing both sides by mu s and g. Now, why did I isolate for r? Because r is the variable that's being compared. So here the question says the radius of the tightest curve. So we're making a comparison for r. So right away, I'm going to isolate for r because it allows me to make that comparison. So here, move mu s and g down to the left denominator. All right, now that you have an expression for r, I'm just going to use it. I'm really going to use the same expression here, but I don't know what v new is, but v new is given to me as double, okay? So here in this expression, the only thing difference here is I added a subscript. So instead of saying v squared, I'm just going to say v new square, and then mu s stays the same, g stays the same, and then here's r new, because you have to find what r new is, right? But I know what v new is. The problem states that it says if its speed is now double, or doubling would imply that you're multiplying by 2. So here in the parentheses, again, I highly suggest when you substitute, use parentheses. Instead of saying v new, I can say v new is 2 times the original speed, whatever it is. And then I want to square that. Now, because you put inside parentheses, you're going to have to distribute, okay? 2 squared is going to be 4, and then v squared is v squared, so I want to just go ahead and carry that down. Again, the 4 comes from 2 squared, and then v squared is that. And then hopefully you've seen my other videos where I like to just pull out the coefficient in front. So here we have 4v squared divided by mu s mu s times g. But the only difference here and this statement up here is this 4. So you can keep the 4 in the numerator, but I just like to pull it out so I can do this little trick. Well, I noticed it on the left side, right? This is my reference point. I have v squared over mu s times g. Well, I also noticed that on the right side here, I have the same term. I have v squared over mu s times g. Well, v squared over mu s times g is r. So where this highlighted box, I can just replace that with r because that's a true statement. So therefore, I can say that r new is 4 times r, the original r, whatever r is. So the answer for this multiple choice question would be D. Okay. All right. I hope that helps. Stay nerdy. Don't be whack.